Hair is a keratinous structure that develops as a result of tiny germinative cells, or stem cells, that generate it. Hair is therefore the result of a cellular process. These cells lie dormant in the epidermis. At a given time, and for reasons that remain unknown, they are activated to start forming hair. At that time, the epidermis enlarges and the stem cells begin to migrate towards the dermis. Once there, the stem cells begin the process of creating hair, starting at the deepest layer. The bulb is joined to the dermal papilla like a clasp. Through the communication established between the epithelial tissue of the bulb and the connective tissue of the papilla, messages are exchanged, leading these cells to start the multiplying of the keratinocytes in the lowest part of the bulb. Hair is thus the consequence of cell multiplication called mitosis. The upward pressure exerted by these keratinocytes is what makes the hair shaft rise to the surface. Hair has the highest cellular multiplication rate in the human body. This explains its incredible growth speed of almost 1 centimeter in just a few days. This growth phase can last from a few months to 10 years and is called the anagen phase. At a given point, the production of keratinocytes stops and the hair enters the catagen phase, which can last from 1 to 3 weeks. The size of the bulb diminishes and it separates from the papilla, beginning its ascent to the surface of the epidermis. This separation signals the hair's death. After that, the hair falls away with the slightest movement. This phase is called the telogen phase. During this period, the papilla leaves the depths of the dermis and remains in a latent or dormant stage for several months. After some time and following some kind of stimulus, which remains a mystery to us, communication between the bulb and the papilla is restored and the hair cycle begins once again. Hair removal is the process through which hair is eliminated from the skin. As we have just seen, germinative cells are the only ones behind hair appearance and growth. So if these cells are destroyed during hair removal, the hair will never grow again. This then is permanent hair removal. To the contrary, if we only eliminate the hair and the cells remain unchanged, the hair follicle will grow again, given that these cells, over time, will generate keratin and hair once again. This technique is therefore known as temporary hair removal. Let's look at several kinds of temporary hair removal. All shaving does, for example, is cut the outer part of the hair, leaving the rest intact. And of course, cells stay alive. After a few hours, the hair emerges onto the surface once again. In the case of hair removal using wax or tweezers, the entire hair is pulled out, but the germinative cells are neither altered nor affected, so keratin is still produced. A few days later, hair is once again visible. Permanent hair removal is only possible, as mentioned above, by eliminating the stem cells. So how can we do this? Right now, the only scientifically proven way is by heating up the hair, which acts as a thermal conductor above 60 degrees Celsius, making the germinative cells in contact with the base of the hair degenerate. The crux of the matter lies in how to heat up the hair, for how long, and to what temperature. How to heat up the hair. The hair can be heated thanks to one of its internal substances, called melanin, a pigment that makes the hair darker or lighter depending on whether it is present in greater or lesser amounts. In addition to giving the hair its color, melanin is also characterized by its ability to absorb a certain kind of light and transform it into heat. If the melanin heats up, the hair heats up. The temperature of this pigment does not rise with just any light, rather only with pure red light or with a diode laser. It is important to distinguish between pulsed light and laser. Pulsed lights have different colors altogether. In this case, melanin only absorbs the red light, so the hair heats up very little. In contrast, lasers only emit one color. The diode laser generates pure red light, and for this reason, melanin absorbs all the light and the hair heats up properly. Now that we know how hair heats up, it's essential to determine what temperature it needs to reach and for how long. The hair follicle must be heated to at least 60 degrees Celsius, and it must reach this temperature in under 30 milliseconds. This way, the hair and cells are destroyed without everything around them being affected. This is the so-called theory of selective photothermolysis. If the hair does not reach at least this temperature for this length of time, the results will not be effective. For this reason, only powerful equipment with clearly determined parameters will achieve permanent hair removal. High energy is needed for this process, and for this reason, it is necessary to have a cooling system that protects the skin. In summary, therefore, to achieve permanent hair removal, a powerful 810 nanometer diode laser is needed that first cools the skin and then emits enough energy to heat up the hair and to generate the hair cells. After a few days, the hair is expelled through the skin and never grows again.